When you are calculating limiting reactants, one of the methods you can use is the theoretical yield method. If this method makes sense for you, great, use it. If it doesn't, you might want to take a look at the reactant stoichiometry method, which is in another video I posted today. To use the theoretical yield method, you will first need to produce a balanced chemical equation for the reaction. We always do that first because we need it for stoichiometry. Second step is you will calculate the theoretical yield of a product from each of the reactants given in the problem. You may choose whichever product of the reaction you like, so long as you keep it consistent, and you should be given reactant masses in your problem. To calculate a theoretical yield, you'll first convert from grams of reactant to moles of reactant using its molecular weight. Then you'll use the balanced chemical equation to convert moles of reactant to moles of product. That's what the coefficients in the equation are for. Lastly, you'll convert the moles of product to grams of product, again, using that molecular weight. Last step is you'll compare those theoretical yields, and whichever reactant produces the smallest theoretical yield is the limiting reactant. And this makes sense. That smallest theoretical yield is the limit of how much product you can produce, given the masses of reactants you've been given in the problem. Let's see this in action. Now we're going to use the theoretical yield method to determine the limiting reagent if we have 3.33 grams of calcium chloride that we're trying to react with 6.12 grams of potassium phosphate. We have our balanced equation. You can check out the other video I put up today if you want to find out how I got it. And we've got the molecular weights of several of the compounds in this equation. Let's get started. First, we're going to calculate the theoretical yield of calcium phosphate from this amount of calcium chloride. The first thing we need to do is go from grams to moles. We get our mole-to-mole conversion factor from the chemical equation. We've got 3 calcium chloride to 1 calcium phosphate. So we've got 3 moles of calcium chloride to 1 mole of calcium phosphate. So we've gone from grams to moles, moles to moles. Now we need to go back from moles to grams. The molar mass is here for calcium phosphate. Crunch those out, and from 3.33 grams of calcium chloride, you could expect to obtain 3.10 grams of calcium phosphate. We're going to do the same calculation, but we're going to start from the potassium phosphate. So we've got our 212.27 grams of potassium phosphate becomes 1 mole of potassium phosphate. And again, we get our mole-to-mole ratio by going back to the chemical equation. So 2 potassium phosphate to 1 calcium phosphate. And now we're going to go from moles of calcium phosphate to grams of calcium phosphate using the molecular weight. Or, sorry, molecular weight. There we go. Crunch those numbers. We get 4.47 grams of calcium phosphate from this much potassium phosphate. Now that we have our potential theoretical yields, we compare them. Whichever one has the smaller theoretical yield is the limiting reagent, because you can only produce
as much product as you have adequate reactant. You're limited by the limiting reactant. Since the calcium chloride produces the smaller theoretical yield of calcium phosphate, calcium chloride is the limiting reagent.